Alright, welcome to the correction video for section 3.2 for Math 135. This is the correction for example 5 and example 6. Alright, so when we're doing the shape of a graph near a zero of multiplicity m, and m is when we're just talking about the number of times we see a specific zero. Let me go ahead and make sure my pen is on. Alright, so it's the number of times we see a certain zero from something. And remember, what are the zeros? Well, the zeros are the intercepts. So then when we have a factored form, for example, like what we have here, and then the values that we see from the factored form would be our zeros, or intercepts. So how would we go about sketching the graph? Now once again, when we're sketching a graph here, we're just doing the sketches. It does not need to be perfect, just the main idea. So the steps that we're going to do, well, first off, we want to go ahead and find the degree of our polynomial and then determine the end behavior. That'll really help us with sketching it. So it would be the degree of this polynomial. Well, we'll just go ahead and think about if we multiplied all of this out, what would be the highest power we would have? We would get x times x times x times x times x, which would give us x to the 5th power. Or degree 5, x to the 5th power. I'm going to go ahead and just write out degree 5. Okay, so we would get degree 5, multiplying out all of those x's. Next, what do we need to do to figure out the end behavior? Well, we need to take a look at the coefficient. Is it positive or negative? Well, in front of it, we just have a positive 1 hanging out, which is going to be a positive. Alright, so we have a positive coefficient, and then our degree is 5, which would be an odd degree. So if we look back at the beginning of our notes for 3.2, we go over when we see a polynomial that has an odd and a positive, the end behavior we get for odd and positive is going to be down and then up. And let me actually write that in a different color. The end behavior down and then up. Okay, great. So we figured that out. Next, what we're going to do is we're going to take a look at these zeros. So I'll go ahead and set up this small chart here for the zeros, and then what we call multiplicity, which is once again how many times we see that zero occur. And the thing about multiplicity is it changes the way our graph moves through the zeros. Let me go ahead and draw a few examples so we get an idea of what I'm talking about. These are not actually for our problem, these are just examples. So let's say we have one option where we have our graph does this. Goes up through the axis and bounces back up. So we have the two zeros, a negative 0, let's say negative 1, and a positive 0, let's say positive 1. Now notice what happens at the zeros, or the intercepts. For the negative one, it just crosses straight through. But for the positive one, it bounces back. That has to do with the different types of multiplicity we might see. So, if, and this is going to be sort of the definition here, if we have a negative multiplicity, or sorry, no, not a negative. If we have an odd number of multiplicity, that means we're going to do a cross, or a graph, sorry, is going to do a cross. It'll just cross straight through. If we have an even multiplicity, then our graph is going to so-called bounce. These are not necessarily correct terms, but that's what happens with the graph. Alright, so if I drew another type of graph, let's say this one here, and then we had our 3 different zeros this time, what would we know about the number of times those zeros occur? Well, because this one crosses, we know that this zero only occurred an odd number of times. This zero, because it bounces, occurred an even number of times. And then this zero occurred an odd amount of times because it crosses through. Alrighty, so that's just a basic idea on what's kind of happening. Now let's take a look at our problem again. What are the zeros that we have? Well, we have x minus 1 and x minus 1 twice. So if I was to solve x minus 1 to find the 0, I get x is 1. So that's one of our zeros. Next, we have x plus 2 showing up 3 times. So if I solve that for my 0, I get x equals negative 2. So we have our 2 different zeros, but the multiplicity of these zeros is different. The multiplicity for the 1 is it shows up twice. Now the multiplicity for the negative 2 is that it shows up 3 times. So what does this mean for our graph? Well, the multiplicity here is even, which once again means that it is going to bounce on our graph. Not the official term, but I'll use that. Then the odd, or the 3, sorry, is odd, which means it's just going to cross. Alright, so we're going to use this to do our basic sketch. So here we have our graph. We don't actually have to label anything except the main points, which are going to be the negative 2 and the 1, which are my zeros. And let's see, what are our end behavior for our graph? First thing to sketch would be the end behavior, because that's what we know very easily. Well, we know our end behavior is going to be down and then up. So from these ends, the first one will go down, and in the very end, it's going to go up. That much I know. Now we need to decide what happens in between. Well, for the 0 of 1, we know that this is supposed to bounce, which means it shouldn't be coming from below. It should be coming from above. Okay, and then what do we know about the other 0, the negative 2? Well, for the negative 2, we know that it is an odd, which means it should just cross. So it should just go straight through. Alright, well that connects perfectly. Look at that. And there we go. We have our graph. Now, I don't know how high up my graph should go. I don't know if it's supposed to go all the way up there or not, but once again, remember this is just a sketch. So as long as you show that it bounces above, you're good. And these are the steps that I'll be looking for when I ask for finding the zeros. Basically show the degrees, the coefficient, end behavior, state the zeros and the multiplicity. So all of these things. And then the graph. Those are the things I would be grading for. So now let's take a look at the next example, example 6. Sketch the graph of p of x. Okay, so the same thing, we're going to be trying to find the different values. We need to find the degree, the coefficient, end behavior, and then the zeros and multiplicity. So let's set that up. The items we need to find. So I want the degree, the coefficient, and then what else do I want to find? I want to find the end behavior, and then I'll go ahead and look at the zeros and the multiplicity. And these will all help me with sketching my graph. So go ahead, pause the video, see if you can try figure this out by yourself and check in with me in a second. Alright, so what would be the degree of my polynomial? Well, we have 1, 2 right there, and then 3. So that's actually going to be degree 4. And my coefficient, let me go ahead and erase this so we can see it better. Ooh, my coefficient is a negative. Alright, so since I have a negative coefficient, and I have an even degree, that means that the end behavior of my graph is going to be down, down. Awesome. Now next we need to figure out the zeros. Okay, so looking at our polynomial here, ooh, we actually have 3 different zeros that are going to happen. We'll have the negative x equal to 0, then the x plus 3 equal to 0, and lastly, the x minus 3 equal to 0. Solving each of these, we get 0, negative 3, and positive 3. Let's go ahead and write this in. 0, negative 3, and positive 3. Now we need to figure out the multiplicity for these. Well, the 0 only shows up once. The negative 3 shows up twice because we have it squared. And then the positive 3 shows up just once. Alright, so now let's go ahead and determine what's going to happen at these. Well, the 1 is odd, which means it's just going to cross. The 2 is even, which means it's going to bounce. And the 1 is, once again, odd, which means it's just going to cross at that point. So now let's graph these and put it all together. As usual, first thing, plot your points. So we have 0. Actually, let me plot this in a different color. Let's go with green. We have 0. Then we have the negative 3. And then we have the positive 3. Now, next thing, end behavior of the graph. Well, we know it goes down, down on both sides. Now we need to determine what's happening in between here and here. Let's use the rest of our information to figure that out. Well, at the 0, we know that it's supposed to cross, which means it should be doing something like this or down like that. We don't know quite which one yet. So since we don't know which one, let's start at the very end dot, which is always a better idea. So at the very end, which is negative 3, we know that it's supposed to be even, which means it's supposed to bounce. Okay, so it's supposed to bounce back. Aha! So then the 0, it's supposed to cross, which means we know it's going to cross up through here. And the last one, the 3, is supposed to cross as well. Okay, so it pops up. We don't know how high. Maybe it goes all the way up and down, or maybe it's just a short little bounce. We don't know which one. Once again, it's just a sketch. You'll figure out how high it would go in later math courses, not in this one. Right now we're just doing a basic sketch. Alright, so then go ahead and it would connect there. So I'm going to go ahead and draw this in the final color, so it's all one color. There we go. So we figured out the bouncing and the crossing. And we have the sketch of our graph using the multiplicity. Once again, if you're told to sketch a graph of a polynomial, these are the steps that I would be looking for. Okay, make sure you state the degree, the coefficient, end behavior, the zeros and the multiplicity, as well as what happens with them. And then show how you found the zeros. And lastly, label your graph. Alright, that is it for the correction for 3.2. Please email me if you have any questions.